we are ready to move on to indicator 9, which indicator 9 we are still working with graphs, but we are going to be analyzing some graphs that are already created, and we are going to be doing some different measurements here. And I apologize that it is a little faded, but whenever you make copies, sometimes that happens. So today we are going to be looking at this graph, and we are measuring time traveled in hours from a boat dock, and then we have our distance in miles. So it says what is happening in section AB. So first of all, we are traveling, and from point A to point B, we are traveling, and rate. First of all, anytime you are doing a rate, you're finding a slope. That's probably the first thing. Change in y over change in x. So change in y over change in x. So I want to ask myself on this one, how much am I traveling from point A to point B? So at point A, I'm at 0 miles away from the dock. And at point B, I am 40 miles away from that dock. So the first thing I'm going to say is that I am 40 miles away. And how much did I travel? I started at 0, and now I'm at 1 hour. So I traveled 1 hour. So I can say that my rate is 40 miles per hour. I am traveling 40 miles per hour. Now from B to C, if you can see how much I was 40 miles away from the dock, I'm still 40 miles away from the dock. So my change in distance is none. I did not increase or decrease my distance at all. I stayed 40 miles away from the dock. So I am here. So 40 miles or 0 miles in 1 hour. So I did not, no change, no travel, 0 miles per hour. I stayed in place. I stayed in place for 1 hour because I didn't move. Now from C to D, I'm traveling again. Now the steepest part of my line is from A to B, so that's my fastest travel. I'm still traveling, just not as fast. It's not as steep. So if you look here, I started out at 40 miles away. Now I'm 70 miles away. So my distance that I've traveled from 40 to 70 would be 30 miles. I went from 2 hours to 3 hours, so that's a change of 1 hour. So I'm traveling at 30 miles per hour for part C. Now from part D, again, my distance changed. It's increasing, just not as fast. So I'm going from 70 to 80. So that's only a change of 10 miles in 1 hour. So slowing down to 10 miles per hour. Now where's the boat at point C? Where? That's my distance. I'm 40 miles, and the distance from the dock, because it tells us that. So we say 40 miles from the dock. Point E, where am I at? My distance is at 80, so I'm 80 miles from the dock. All right, and then my last question says, which segment shows the boat's fastest rate? I think I already explained that. But whenever you have a faster rate, we're talking about slope. So the fastest rate would have the biggest increase in slope. So we're looking for the steepest line. And that segment is AB because it is the steepest segment. It is the steepest segment. So just remember, when you are doing rate, you are finding slope. You're comparing how much you're changing in the y-axis, how much you're changing in the x-axis. All right, now let's move on to this next example. We are comparing walking of Mrs. Walker and Mrs. Hyatt. So this time we are comparing the distance from the school in miles and the time hours that we walked or ran, depending on our rates. You might think I'm a runner, not a walker. So the first thing I want to ask is, who is faster and why? So think about what we just said. The faster rate has a steeper line. So if you look at Mrs. Hyatt's line and you look at my line, the faster person would be me. I think if she actually wanted to race me, she runs more than me. If we really wanted to go on a foot race and start running, she would smoke me. Now the second part, it says, how fast is Mrs. Walker? So I have to have 2 points to compare. So I would compare this starting point and then this dot that we can read. So if we go here, all right, so I start out at 0, and actually my ending point is a good point to start as well. So if you can see, I travel 4 miles, so my change in y over my change in x. That symbol, that triangle, just means change. It's actually a Greek letter delta, which represents change. So I travel 4 miles in 3 hours. So I go up to 4 miles, I go over to 3 hours. So 4 miles in 3 hours. And so that actually, if we want to divide that, it's about 1.33 miles per hour. Now, how fast is Mrs. Hyatt? Now, she starts 1 mile away from the school. She ends up 4 miles away from the school. So if she starts at 1 mile and ends up at 4 miles, she travels 3 miles. And she starts at 0 and travels 4 hours. So that's 0.75 miles per hour. Now you can definitely see I'm faster here. We figured it out by just looking at the steepness of the line, but now that we have calculations, I'm significantly faster per this graph, not real life. All right, now the question D, it's saying, at what time and distance from the school will Mrs. Walker and Mrs. Hyatt meet? So where do you think on this graph we are meeting or crossing paths? Definitely where our lines intersect. So if we look here, at what time, we go down, we meet at 2 hours. And what is my distance? Let's say about 2.5. It's right in between 2 and 3. And so we would say 2.5 miles from the school. Because it's not just 2.5 miles. We're measuring distance from the school. Now it says, why do the teachers have different y-intercepts? So the y-axis is measuring distance from the school. I start at 0. Mrs. Walker, I start at 0. So that means if I'm 0 miles from the school, that means I start at the school. So if we can see this, I can say Mrs. Walker starts at the school and Mrs. Hyatt starts 1 mile away from the school. Away from school. Sorry, I'm running out of room. All right, so we are running away from school. No, we're not running away from school. We're still at school. But she's a mile away from the school. All right, it says express each teacher's starting point as an ordered pair. My starting point is 0, 0. And the X value represents the time.
Mary, please come to the office.
And the Y is the distance from school. And then Mrs. Hyatt starts out at 0, 1, where X is representing her time. We have not started yet. And the Y is the distance from the school, which she is a mile away. All right, now it says, how long will it take Mrs. Hyatt to walk 7 miles from the school at her current rate? So if you look at this, her line if you wanted to write an equation for her line, mx plus b, we know her slope is 0.75. We found that from this example. All right, then we know her y-intercept is at 0, 1. And so we can say our b value is a +1. So if we wanted to plug in 7 miles, that's going to go in for our x. So 0.75 times 7 plus 1. So then you can get a calculator out, which I'm going to grab mine real fast. And you can see I'm going to take 0.75 times 7, which is 5.25. And then add my 1. And so I get 6.25, and that is going to be measured in, oh, scratch that, ignore me. That was a mistake. Hey, my mistake. Miles is not my x, it's my y. So 7 equals 1 or 0.75x plus 1. So we're going to solve this equation. We're going to subtract our 1, and then we are going to divide 6 by 7.5, or 0.75, and we get 8 hours. I'm going to say, sorry about that mistake. If you guys have questions, don't hesitate to reach out, and I will see you guys all soon, and have a great weekend.